Okay, hey everyone, welcome to Lab 4 for the Introduction to GIS and Cartography. I'm your teaching assistant Kripa, and today we will be looking at different projections and coordinate systems. So that's going to be fun. It's going to be a pretty long lab, so brace yourselves. If you're dealing with any issues or need help with the assignment or the labs, just feel free to reach out to me in my email. So, okay, let's start. So yeah, that's the regular drill. Go to your course in Canvas, download your file if you haven't already. So I'm sure you guys have already downloaded it to wherever you've preferred. If you're using your local machine's C drive is perfect. If you're using Citrix or any of the lab computers, be sure to save everything inside the network drive. It's just a gentle reminder. And yeah, so go ahead and unzip these files. And it should look something like this. Okay, cool. So the first instruction says to examine the Excel file. So let's go ahead and open it. So the thing is, so yeah, this is showing, this has like a tabulated version of all the power plants that's in Utah. So it has all the name, the carbon dioxide emissions, the code, what type of fuel they're using, and these are the coordinates. And as you can see, this looks a little or like way different than the regular latitude and longitude that we use. So yeah, the first thing to do is go ahead and save this as a CSV, because ArcGIS Pro, if you like want to import an Excel sheet, it's going to be difficult for ArcGIS Pro to display the data, and there's a large tendency that it might crash. So we want to avoid that. Go to File, do a Save As, and just under the drop-down menu here, select CSV and save it. So I've already done it. It's right here. And let's go ahead and open ArcGIS Pro. Okay, so let's give it a name. Save it to your desired location. Okay. Okay, so the first thing that I want to ask you guys, just throwing out a question there. So which projection do you think this data is in? Like just this topographic layer, that's the default. If you just zoom out, you can see that this whole world map is in a shape of square. And just think for a bit, why is it the way it is? Like, why is Greenland and Antarctica so stretched out and it looks huge? And we've already studied in our lecture recorded by Alex. I think he's pointed out that this is not true. And the answer is this is in a cylindrical projection, and this is a Mercator map. And the reason behind these two of these things looking so weird is that the farther you go out of the equator, the more stretched out things become inside the map. So just that was like a brief introduction to Web Mercator. If you guys don't believe me, you can just go ahead and select the topographic layer, go to Properties, go to source and see for yourself under spatial reference. There you go, it's under Web Mercator auxiliary sphere. I always have difficult time pronouncing that word. Okay, so let's go ahead and follow our instructions. So we want to add our data, that is the CSV file. So go to map, under add data, select XY point data, and you should see a geoprocessing tab open up in your in your catalog pane. We want to input our table to our CSV. So let's do that. Okay, let's click on our CSV and let's hit run. So there you go. You cannot see anything, and the reason behind this is, okay, let's go ahead and select this layer and open our attribute table. There you go, the coordinate system, that's the issue. So the coordinates here are not what we've expected. So these are right here, if you just hover over, your X field is supposed to input your longitude, and your Y field is supposed to input your latitude. And as you can see, they're not in latitude or longitude. So yes, so while running the geoprocessing tool earlier, we selected a GCS WGS 1984 coordinate system. So you must be wondering how or what projection is the correct one. So let's go ahead to our catalog and let's add our folders. Once again, navigate. So this is my home folder. I'm not going to select that. I'm going to select this one. It says lab 4. Let me expand it. So there you go. So yeah, right now we cannot see a thing. If you try to zoom to this layer, it's just a blank canvas. Okay. So these were supposed to display power plants in Utah, and as of now, we don't see anything, right? Okay, so let's go ahead and uncheck this, bring it to the bottom, and let's add the shapefile. This is going to give us the answer. So there you go. Now it is displaying all of the power plants. So let's go ahead and see its attribute table. The same points, the coordinates are just the same. And if we right click, go to properties and see its spatial reference, this was supposed to work with the NAD 1983 UTM zone 12 north. So who would have guessed? I mean, yeah, so that was like the whole point of making you guys do this step. So we're gonna go ahead and we're gonna create a layout map. We're using different symbology to distinguish the field types for each plant. So let's go ahead and do that. Click on the UT power plants, the shapefile. You can get rid of this, so I'm just gonna remove it. Right click, do symbology. We want unique values because we're gonna color code it, or just have like also use different symbols. For field, select fuel, and there you go. Coal, natural gas, oil, and other. Let's get rid of all other values. These are redundant, and just go ahead and play with symbology. So I'm gonna use different symbols here. I'm gonna use okay, like a square for this one. You guys can go ahead and reduce the size this way, increase it, decrease it to an 8. Okay, that looks fine. Same thing for the others. So for natural gas, let's go to gallery, select a triangle, maybe a black one. Oops, let's stick, okay. Maybe, okay, that one. So once again, I'm gonna reduce the size. Maybe stick to 8. And something like a circle for oil. Or maybe let's do a pentagon. Go ahead and reduce the size if you want, or not, that's fine as well. And that's interesting. Okay. Yeah, you can see like an overlap there. Okay. For others, I'm just gonna select a simple circle. Just reduce the size. Great. So should look something like this. And let's create a new layout. So go to Insert, do a new layout, do a letter, select Map Frame. Just the usual stuff, guys. Yeah, if you want to go ahead and zoom in, right click on Map Frame, do an Activate. If you guys want to change the base map, that's fine as well, but I think I'll just stick with this. Okay, cool. So I'm just gonna save it. Go back to layout. Like I wanted more zoomed in. Yeah, that looks better. So, and just the usual stuff. Add your key map elements. So go ahead, add your north arrow, your scale bar, try and move it to 100. Okay, perfect. Add your legend. That's important. Looks good. I think I'm okay with that name. Yeah, I don't want to change it, so I'm gonna go ahead and add my title. That's under symbol, layout, title. Do they want us to give a particular name? Oh, I don't think so. So, just gonna write displayed as field type or something like that. Yeah, I think that's fine. And give yourself the credits and today's date. So there you go. The usual thing, take a screenshot if you want, and also for a good backup, and export it. Lab 4, and just do like a lab 4 deliverable 1 or something. So if your ArcGIS Pro has not crashed, I think you've exported your map. So I'm gonna go ahead and close this. Let's go back to our map. I think we're supposed to close this as well. Yeah, so we need to start a new ArcGIS project altogether. So just gonna save this and close it. Okay, gonna open it again because my software, like the version that I'm using, does not allow me to open a new project while an existing one is still running. So give it a name. Or something like that. Navigate to where you want to save it. Okay, there you go. And we'll be dealing with some fun stuff now. Okay, so we're gonna create a new map and zoom to the extent of the continental US. Okay, let's do that. Okay. You see a bit of Alaska. I think this is fine. And we want to create a layout map with a title stating the coordinate system used to find out which coordinate system is being used. Check the map's properties. Okay, that's easy. So go ahead and select your topographic layer. Go to properties. Go to source and select spatial reference. So yeah, it's WGS 1984 Web Mercator. So I'm just gonna go ahead and copy this, click OK. They want us a new layout. They want us to create a new layout. So great. Once you zoomed in, I'm just gonna go ahead and you guys don't need to have any map elements up here, so just go ahead and just give it a title. Okay. There you go. So save it, export it, take a screenshot as well. It's good practice. If your ArcGIS Pro crashes, 2 or something. Alrighty. Next step. So we want to change the coordinate system to the coordinate system used in part 1. So for part 1, we used, it was NAD 1983. So let's go ahead and change this. So right click on it. Oops, no, select your map. Go to properties, go to coordinate systems, and go ahead and find NAD 1983. Okay. All right, here you go. NAD 1983. Select. I think it was. Okay, wait. I don't think we're in the USA. Okay, wait a minute. Let's do world. Nope. Let's do North America. Okay, I think the first one that we were using, I think that's the one we want to use. So go to continental again, select North America, and select NAD 1983, this thing. We'll do an OK. Okay, yeah, that is exactly what we want. So let's go ahead and get. So yeah, your layout should, if you've not already crossed it out, if it's still there, your layout should show something like this. And we wanna change this. So properties. Just go to map and go to properties. Type that in. (2001). Oops. Contiguous USA Albers. And 1983, 2011, contiguous, oops, contiguous Albers, or it's okay if you just do like NAD 1983, 2011, that's perfectly fine as well. Once again, save it, export it. Okay. So now we want to create a final nationwide map using an equidistant or an equal area projection. So it's either equidistant or equal area projection. So once again, go to your map and go to properties, go to coordinate system, and let's head towards just navigate towards your equidistant or equal area map. This is going to take a while for you guys if you don't know where that is, and you can just go ahead and see for yourself. So yeah, it's under projected coordinate system, continental North America. So I don't know if you have all of these because we might be using different versions of ArcGIS Pro, but the idea is just to find an equal area or an equidistant conic. So I'm going to go ahead with the equidistant conic. And you should see something like this show up. And let's just zoom in a bit, and they want us to measure the distance between New York's JFK to LAX. So we don't have that on our map, but we can just do like a simple New York to Los Angeles. So go to your map, the map tab in your ribbon, do a measure distance. So click on New York and Los Angeles. oops, just do a double click. And for the metric, let's do a geodesic first. I think that's what they want us to do. So they want us to record the value to the nearest mile. Miles are using both geodesic and planar options. Okay. So this is for geodesic. New York to, oops, don't think that's right. I'm gonna clear everything. It's to Los Angeles to New York. Let's do it in miles. Okay, I'm difference from New York to LAX, so it's the opposite way. Sorry about that. Let's do geodesic. Cool. So from New York to Los Angeles. So you should see like a path net bearing of 274 or something. So go ahead and write that down or take a screenshot, whatever you prefer. So we have 2,457.24 miles, and our path net bearing is 274 degrees. Okay, let's do for planar. And as you can see, there is not much difference in the path net bearing, and the path in miles is not super significant. I think it's just by like 100 miles or something. So yeah, just go ahead and record that difference. Take a screenshot. That's fine as well. So once that's done, we're gonna close this. And I don't think we need the layout version as well. So yeah, you can go ahead and click this one off. So cross that out. And now the next instruction is to find a list of the top 10 global power cities from the website of Mori Memorial Foundation, and we are going to identify the UTM zone for each of these cities and the row within which they lie using the World UTM Grid, which is an online feature that we can extract from the portal option in our catalog pane. Okay, that was a lot to take in. Let's go ahead and go to your browser. Just go to this website. Okay. There you go. You should see something like this show up, and explore the website. So you're gonna see something like a global power city index show up. And give it a read if you want. And these are the 10 cities that we're interested in looking at. So we want to see like under which UTM zone they fall under. So go ahead and keep this window open, and let's go back to our ArcGIS Pro. So in your catalog pane, so we're under project. Just beside that, you can see something like a portal show up. And this has my content, shared contents, or group content. This is all portal, and this is the living atlas. So we're gonna go ahead and click all portal, and we're gonna search for World UTM Grid. There you go. You see a bunch of stuff. So this is a layer package. This is a feature layer. This is a web map. So I usually prefer just going with the layer package. So right click on it, do add to new map. So you'll see another map show up. And if you zoom in, you're gonna see, okay, there you go. It's gonna take a while to pop that up. So you're gonna see different UTM zones. So the whole map has been divided into these UTM zones, so that's really cool. So let's go ahead and look at our first city. Let's go to New York. Okay, you can go ahead and zoom in. So there's New York. If you select it, you're gonna see a pop-up, and that's gonna show you which zone it is in, which row it is in, its west value, its east value, all the fun stuff. So go ahead and, so this is grid 18. So go ahead and copy paste all of that into a Word document and have this set up. So this is the deliverable that we're interested in. Okay. So let's do that for the rest of the cities. I'm just gonna do a few. Let's go to London. There you go. Here's London. So same thing. Just copy paste the pop-up and paste it in your Word document. So I think that's it for today's lab. So there's going to be like 4 deliverables that I need from you guys. The first is the layout map of all the Utah power stations. That should look something like this. And 3 layout maps of the continental US using different coordinate systems. Also a short write-up that has the recorded value of the difference between each projection and properties. Oops. And the distance measured between New York and Los Angeles, and maybe give an explanation of why they may vary by like a couple of, or like 100 miles or so. So just, yeah, for the deliverable 3, I want you guys to just like go ahead and brainstorm like which projection or datum according to you would fit best for the nationwide map. And finally, I want a list of all the top 10 global power cities and their UTM zone and the row where they are located. So yeah, the thing is you guys can just do, have these 2, that's fine, or like select all of that. That's okay as well. So yeah, good luck with lab 4, and I'll see you guys next week.